Decision analysis, decision making under risk. In this video, we shall be talking about decision making under risk. At the end of this lesson, learners should be able to define decision making under risk, itemize 3 criteria for decision making under risk, analyze the decision situation under risk using the 3 criteria. I'm Operation Research Facilitator. My name is Abdullah Falade. Decision making under risk. This is a situation whereby you have more than one state of nature and you have sufficient information to assign probability estimates to each state of nature. So the probability you obtain could be from past record or from subjective judgment. The payoff associated with each decision are represented by probability distribution, and decision can be based on the expected value criterion. What are the 3 criterion for making decision under risk? Expected value criterion, expected opportunity loss or expected regret criterion, and Laplace criterion. Let's take it one after the other, using a typical example. How to use a criteria with typical example. This given payoff represents the possible profit associated with erection of a building on the land, but the problem is, in which type should we recommend? Which type should we recommend? We have the decision alternative, more than one state of nature, low, medium, high. We have 3 decision alternatives, D1, D2, D3. And probability is assigned to each of the states of nature. 0.25 for low, 0.3 for medium, 0.45 for high. Take note, the sum of the probability must be equal to 1. So, in a case where you have one unknown, add the given and subtract from 1. You will be able to get the unknown. The first criterion we shall be talking about is the expected value criterion. The criterion seeks the maximization of expected profit or the minimization of expected cost. In this case, we have the payoff profit payoff table. In a case whereby you have cost payoff table, you minimize the cost. The data of the problem assume that the payoff or the cost associated with each decision alternative is probabilistic in nature. The criterion requires the calculation of the expected value of each decision alternative, which is the sum of the weighted payoffs for that alternative, where the weights are the probabilities assigned to the state of nature that can happen. Expected value criterion is also known as expected monetary value, EMV. How can we apply this criterion? You multiply the probability estimate by the corresponding value for each decision alternative. For decision alternative D1, the expected value for D1 is 200 times 0.25 plus 100 times 0.3 plus 400 times 0.45. By computation, you have 260. You do the same thing for D2. Expected value for D2, you get 205. Expected value for D3, you have 285. Do not forget that we have explained earlier that we are dealing with profit payoff table. In that case, we try to maximize profits. So we consider the decision alternative that has the highest expected value, and by conclusion, we said by the expected value criterion, we recommend the decision maker should adopt decision alternative D3, since the decision alternative D3 is the one with the highest expected payoff, 285. Also, we can have expected value of perfect information. To determine the expected value of perfect information, firstly you need to determine the expected payoff with perfect information. Take note, there's a difference between expected value of perfect information and expected value with perfect information. So the first thing to determine is the expected value with perfect information. How do you go about that? Check under each state of nature what is the maximum value. 300 under low, 400 under medium, 400 under high. Multiply the probability estimates to each this maximum value. By computation you have 375. This tells that your expected payoff with perfect information for that problem is 375. What about the expected value of perfect information? You need two things. You need the expected value with perfect information, which has been calculated to be 375, and the maximum of the expected monetary value. So 375 minus 285 gives 90. So the expected value of perfect information is 90. If you are watching this video for the first time, do not forget to subscribe and press the notification bell to enjoy more videos. The next criterion we shall be talking about is the expected regret criterion. We are still using the previous given payoff table. Expected regret criterion is also known as expected opportunity loss. The expected opportunity loss is an alternative approach to maximizing EMV. The approach is to minimize expected opportunity loss. The expected opportunity loss represents the amount by which maximum possible profit will reduce under various possible stock actions, and the course of action that minimizes these losses or reductions is the optimal decision alternative. What are the steps involved? 1. You identify the maximum of each state of nature. You calculate the regret, which is maximum payoff minus payoff for each state of nature, and then you multiply your regret with the associated probabilities, and lastly you choose the minimum expected opportunity loss. Let's apply these steps. The maximum on the low is 300. 300 minus 200, 300 minus 100, 300 minus 300. The maximum on the medium is 400. 400 minus 100, 400 minus 150, 400 minus 400. The maximum on the high is 400. 400 minus 400, 400 minus 300, 400 minus 200. So by the time you calculate that, you will get this payoff table. And by the time you get this payoff table, you can now determine the expected loss for each of the decision alternative. So the expected loss for D1, that is 100 times 0.25, 300 times 0.3, and 0 times 0.45. And the expected loss for D1 is 115. The expected loss for D2 is 170. And the expected for D3 is 90. So by that you can determine the smallest of all the expected opportunity loss. And you can realize with me that we are going to consider the one with the least, because our focus is to determine the minimum expected opportunity loss. Laplace criterion. Laplace criterion is also known as principle of insufficient reason. We've explained that earlier, and it assigns equal probability to all the events of each alternative and select the alternative associated with the maximum expected payoff. So I come up with this formula from the understanding of Laplace criterion. We have the state of nature, so that's 1 over 3. For expected payoff D1, 1 over 3, 200 plus 100 plus 400, you get to 33.3. expected payoff for D2 183.3, expected payoff for D3 300. So you choose the highest of this. So we have been able to justify that by the Laplace criterion, D3 should be adopted because it has the highest expected payoff. I hope you've learned one or two things in this video. We have some practice questions which can help you to evaluate what you've learned so far. Thanks for watching and bye for now.